Okay, class, today we're going to talk about volume of various figures. I'm going to bring up a bunch of stuff from the book here. So just pause for a second. Okay, here's four volumes we're going to look at, four different types of shapes. So we first have the box, and the volume of a box is the length times the width times the height, or if it's a cube where all the sides are the same, it's still length times width times height, which you see here, side times side times side, which ends up being side to the third. So that's just kind of a special case. The cube is a special case. But length times width times height. The volume of a pyramid is 1/3 base times height. Okay, so we're the base here, guys. This base is referring to the area of this entire base. Okay, down there. I don't know if you can see that, but there's this has a rectangular base in the picture. You could actually have a triangular base. That'd be fine. So the B is the area of the base, and then H is just simply the height of the pyramid. Okay. All right. Now let's look at a right circular cylinder. So where you've got, a circular base. Here's your circular base down in here. Right? Kind of see that? So basically, it's pi times the radius squared, that's the radius, times the height is the area of volume. Okay, so volume is the amount of matter that's in that space. Like if it were a cylinder, it'd be the volume of water you needed to fill it, or if it was made out of steel, like in this case, a pyramid made out of steel, it'd be the amount of steel that you're using. Okay. And then the volume of a sphere is 4/3 pi times the radius cubed. Okay, so we're just going to use these now. All we're going to do in this section is just apply these formulas. So we're going to jump right into problems right now. Okay? This will be a very short section. All right, well, here's an example of a right circular cylinder. So the volume of a right circular cylinder is pi r squared h. This one's on its side, so the h is 12, even though it's on its side. Now, confusing here is the radius. Well, they actually gave us here the diameter. This is the diameter. It's the distance totally across. The radius is half of that, right? So the radius in this case is going to be 7. So the volume is pi times 7 squared times 12, which on my calculator, pi times 7 squared times 12 is, if I round it, if I put the pi in, I get 1847.25, but we're going to round it to the nearest whole number. And this is in cubic centimeters, okay? So it's important to recognize that. So the perimeter of something is in units, okay? The area is in square units, and the volume is in units cubed. So if it's centimeters, perimeter would be centimeters, area would be centimeters squared or square centimeters, and volume be centimeters cubed or cubic units. So you got to get the units right in these problems. Okay, so we're just applying formulas here. This is not a super hard section. Let's try the next one. Okay, this is the volume of a cone. Well, the volume of a cone is 1/3 pi r squared h. Okay, I don't think that was one of the ones I gave you, but I'm giving it to you now. This is a cone. Okay, so my radius looks like my radius is actually 3, because they give me a diameter again. And my height, this is my 8, h is 7. So I can plug all this in. This is not hard. Pi times 3 squared times 7. So that'd be pi times 3 squared times 7. And then divide that by 3 or multiply by a third. And I get approximately, whenever I'm rounding, I need to put a little approximately equal sign. 65.97 cubic yards. So yards to third power, or you could actually write this, by the way, guys, you can write this right here in words, cubic yards too. That means the same thing. So sometimes you'll see it written that way. Or cubic inches, or so on and so forth in the homework. Okay, this one's a little harder because we've got two parts to find the volume. This is what, kind of like an ice cream cone, I guess you could call it. We first have to find the volume of the bottom half of it, which would be a cone. And then we got to find the volume of the top ice cream part, which is going to be a hemisphere, half a sphere. Okay? So the total volume is going to be the volume of the cone plus the volume of the hemisphere. Right? Well, let's work on those separately. The volume of the cone first. That's going to be 1/3 pi r squared h, which is 1/3 pi. The radius appears to be right here, and it's 5 because the whole distance is 10. The diameter is 10. So that'd be 5 squared. And the height of the cone is right there, is 8. So what does that give me? Let's look at that. In the calculator, pi times 5 squared, which is 25, times 8. And then divided by 3 or multiplied by 1/3, same thing. I get 209.44. Okay, now let's look at the volume of the hemisphere. Well, the volume of a hemisphere, the volume of a sphere is 4/3 pi r cubed. But since this is a hemisphere, don't I want to cut that in half? Right? I want to cut that in half because that's the volume of a whole sphere, so I got to cut it in half to get the hemisphere part. Okay? So this would be 4/3 times pi. The radius again is 5 to the third power, and I'll multiply that by a half, which comes out to 4 divided by 3 times pi times 5 cubed. When I plug all that in my calculator, I get 261.80. And I add those, so the volume of overall is the sum of those. Is that. And so that is the volume of that situation, okay? And let's do another one, but we're not going to do the whole thing. We're just going to talk through it. Okay, so this is very similar to the last problem. The only difference is we got two parts we're going to take the volume of. We got, first of all, this bottom half right here, which is a right circular cylinder, which we have the formula for. And then we've got this cone on top that we got to find the volume on. Okay, so the overall volume is going to be the volume of the cylinder plus the volume of the cone. So, but one tricky part of this problem, I was going to point out, is all the things are easy to find. You can see that the radius here on both the cylinder and the cone is going to be 3 because this is 6, and that's the diameter across. So we have the radius of both of them. What's a little tricky is just make sure you've got the height. This is the height of the cylinder. But the height of the cone, which is this distance right here, looks like it's going to be 5. And the way you get that is you know that the full distance is 17, and then this distance is 12. So if I want to find the distance from here to here, I've got to take the 17 minus the 12. Okay, so you guys can do this one on your own because it's just plugging in numbers to formulas, but I at least want to show you how to get this this height right here of 5 by taking the 17 minus the 12. All right, so that should get you ready for the homework. And here is your Easter egg, by the way, for this one. 928,137. That's 928,137.